Hello, this is your host, Luke Schantz. In our last episode in this exploration of application modernization, we discovered that modernization is a holistic and circumstantial undertaking that encompasses code, infrastructure, pipelines, as well as the culture and the ways in which your teams work. In this episode, we're going to continue our exploration with the topic of architecture. I got in touch with Dewan Ahmed from Red Hat because I heard he was knowledgeable on a variety of topics. And to start off my conversation with Dewan, I rattled off everything I wanted to discuss with him. So let's pick this up here.
Oh my, Luke, you are hitting all these points, which just each point I could probably talk for a few hours. And I'm so excited and passionate about each of these topics. So let's start with architecture. So when we talk about architecture, there's a monolith and there's microservices and there's serverless. So most people try to space the architecture in these three categories. So for those listeners who are completely new to application modernization landscape, understand what monolith, microservice, I'll just give one quick overview of what these three separations are. So monolith is a type of architectural design where all of your application are typically written in one programming language. And then your whole application is like a one stack. So from back end to the front end, it's one piece. And that's connected to some database. So if you want to make one code change, you have to stop the running application and then make changes and deploy the whole applications together. Whereas in microservices, you break down each application into small pieces. So let's say if you're thinking of an airline application, the UI of that airline could be separate microservices. And the backend could be two different applications. Maybe one application is calling some API, the other part is doing some background logic, and then it's talking to, let's say, one other database. So this is what microservices, where the two main concepts is each of these small pieces can function on their own. So if you look at one small piece, that can work on its own. And the second point is they're typically running in containers or running as containers. So now the final piece is serverless model. So in serverless model, of course, there's always servers, but the idea is you define some functions or logic and you don't care of the underlying structure or what VM it's run or what container it's run or of course, what server it does it run. You don't care about that. You just define that I need this cron job to fetch these data for me, and that's it. So let's say if this is a Node.js serverless functions, you define that, and what happens underneath, you don't care about that. Whereas in containers, you actually do, because in containers, in the Docker file, you actually specify the base image, so you have some interaction with what the underlying operating system is, some interaction with the memory and whatnot. So to sum up, monolith, microservice, and serverless model, these are three architectural patterns on how we build, deploy our applications. So each has its own pros and cons. So we cannot go about saying that monolith is the way to go or microservice is the way to go. It really depends on the customer's specific need and where they are in their journey.
So it's clear that the microservices paradigm is really prevalent across a number of containerized and serverless architectures. So I wanted to dig a little deeper into what that means to the architect and to the developer. So here is an excerpt from my conversation with Mike Spisak, CTO of the IBM Security Garage. And I asked Mike specifically about the idea of monolith to microservice.
There's a number of key principles that employing an architecture like this will provide lots of different benefits. And I think a couple of them are, and again, debatably, but easier to maintain and build some of these apps. When you take something that was once whole and you split it up into these smaller, what I'll call bite-sized pieces, it becomes a lot easier to build and maintain them when they're smaller fragments. And then once you have these smaller fragments from an architecture perspective, they become composable. So you could start to string them together in new and interesting ways. That's probably one of the biggest benefits that you'll see. And then on top of that, there's all this other stuff that starts to happen. For example, improved productivity and speed, especially in the agile world. You can now break your teams up into smaller teams, right? Now that you have smaller components, you can have smaller teams, what I like to call pizza-sized teams, which often makes people more effective. They allows them to maniacally focus on one thing instead of having to always worry about this larger holistic thing, which again is more of the architect's job anyways. Also provides some flexibility in choosing your stack and your technology. Now that things are broken up, different microservices can be run on different technologies and different platforms and different programming languages, which allows us to play into the strengths. Choosing the right tool for the right job is probably a good way that I would summarize that. So, I mean, really, in closure, on top of all of that, and this is an area that's near and dear to many of us, is when you have things in this way, you sort of get this ability to have continuous delivery, right? So from the old monolith world, if you changed one thing, you'd have to redeploy the whole thing, right? And then in the new world, if you change one thing or 18 things, you can just restart those individual components without having to take the whole application down. And this allows us to do things much faster, much more economy of scale, and basically enables that continuous delivery that we're all after.
I liked how Mike described how not only the code is broken up into smaller fragments, but also the development teams can be divided into smaller, more focused work groups, which I find fascinating that there's a similarity between the architecture of the application and the culture of the work, which is also a good reason to build your systems with the best practices and the right help, as these are the systems that you and your coworkers are going to have to work with every day. So, be kind to our future selves here. Let's dig a little deeper into what this type of architecture means from the development perspective with some thoughts from Andrea Crawford from the IBM Garage.
The developers and application squads not have to worry so much about designing all of these sort of base functional things, but frees them up to innovate more at the application layer and not have to worry about, I can remember the days when it actually mattered, like what hardware architecture you were running on or what version of an operating system you were running on because you had this compiler dependency. These things are becoming more and more abstracted from the application layer, which sort of frees people up. So the architecture and the commoditization of a lot of these base functions into this layer frees up the application developer. So the architecture is really freed up for that type of innovation.
Well, thank you, Andrea. And I wanted to know more about that type of innovation from a development perspective. So I want to share with you part of my conversation with Mary Grygleski, who is a Java developer from Chicago, a fantastic advocate, and here's what she had to say about microservice architecture.
So for architecture, we've been hearing a lot about monolith to microservices. With that, I cannot help but also bring out the concept of, say, reactive and event-driven world. And that's actually, it's more mimicking the real world. Okay, so I think we should first kind of go back in time. What used to be computing is that everything is very synchronous. We need the computer to do some work. So we need to give a sort of command. It can run in a command line. It can run as a GUI and all these things. So you give the instruction, there's some input you need to give to it. And then basically the computing side, it will receive this input and then it will process and do things accordingly. Then it will send you back an output. So the input and output, everything was done very synchronously. You need something, give what you need, and then you wait. That's the key. You wait for the processing to be done, then you take it back. So very monolithic, so to speak, in some ways, and that's what our systems used to be. Because also hardware too was very much like single CPU. You only have one CPU kind of doing things. So everything too is like, okay, you need it, then I'll wait, right? So in this case, it's like you need to have a more creative way of doing things. So here comes then all of the reactive architecture that comes in, that essentially you can actually have new ways of utilizing this hardware and making it more functional, even more functional. So then it also brings in the reactive, and reactive is really perfect timing because we don't wait, right? Let's say we go and to order food, we're hungry. And we go to the restaurant, maybe we're shopping too. We're like, okay, let's go and we'll order some food. We get the ticket and we go and do other things. So that's the idea, is that, the architecture will allow us to do this kind of things in which you give the request. There's no need to wait for things while they are being cooked. they are being processed. So you go off and do something else. In the meantime, you hold on to your ticket, and when you're done shopping or when the food is ready, you get a notifier. Then you go and pick up your food. Think of like how much more efficient it is. And so in today's world, it becomes a necessary thing that we need to do processing in a new way. It's sort of like the microservices architecture fits very well into this new way of thinking, because then if you think of like old way of doing things on monolith and everything is all bundled up in one single process, then the whole thing needs to wait for you. So there's no need to. You need to break it out into different pieces. They are all individually responsible for something else. And in the meantime, all of these components, right, in the computing terms, these components will communicate with one another through messaging. And that's the primary kind of a way all of these components are able to communicate with one another. So it's funny. It's more like thinking of ourselves living in a highly functional way in which all of the components are very tightly synchronizing with one another through messaging, through all of these event-driven mechanisms that you can actually still maintain certain level of states in between these other things. So I hope this is kind of giving a more practical explanation of like from monolith to microservices, and it is becoming necessary because you're breaking things up. You don't tie everything together, but yet we have new mechanism of tying them up together so that the end result is that we're not wasting time in between in the wait time. So that's how I look at the world, and also like event-driven and reactive, all of these things that fits itself very well in this new way of doing things like microservices and very diverse type of universe in this case.
I loved how Mary related the asynchronous activities of our daily lives to the microservices architecture. We're going to hear more from Mary when we get to our refactoring episode in this series, but I wanted to check back in with Brandon about how security fits into architecting an application modernization strategy.
So we have these old, huge monolithic architectures for these huge ERP systems or banking systems. Now we can break them down into this microservices architecture to where you need one function to talk to one app. You can do that, right? Or one person or one system. That's awesome. The flip side of that is there's just so much more complexity. So I used to have this one architecture. Now I have 600 containers I broke it down into, right? And then it comes in the fact that each container might be doing something different. So we might containerize a database, or we might containerize an application, or we might containerize some middleware of some kind. All of those have different security requirements, right? So how do we effectually make sure the security of that is taken care of? We need to prevent lateral movement. And what I mean by that is just because we have a container in our cluster doesn't mean it should talk to all the other containers, right? Because worst case scenario, some malware gets into that container, and if it can move around, all of a sudden it's in our whole cluster. But if you do container security right, you shouldn't hamper speed at all. And it should allow you to do more things and be more quick. If I affect security policy and I ensure, for example, this container should only talk to the database container. If something goes wrong with one container, it's easy for me to spin a new container up and replace that and have that interchange, right? So still leads to the speed and flexibility thing, but there is an expertise around how we drive security policy, how we architect it. And then there's how we deliver containers into production, right? So those are the security things that need to be taken into account that usually we don't see as of today, but people are getting more mature as they're driving those.
Well, it's becoming quite clear after digging into my conversations with our guests that microservices and containerized workloads are going to play a big part of many modernization initiatives. And to successfully implement an initiative like this, we're going to need the right architecture, the right tools, the right talent, the right skills, and of course, approach it with security in mind. In our next episode, we're going to dig into containers and the tools and techniques you can use to orchestrate them.